Welcome to the Slop Temple. We pray this video helps.
You start by labeling every independent loop and choosing a consistent direction for each mesh current. Clockwise is fine. Once done, write mesh names like I1, I2, I3 at the loop centers, and mark polarity across resistors according to assumed current directions. Make sure to note which elements are shared between two meshes because they create interaction terms. Draw arrows on shared resistors. This sets a clear map, so you can convert the circuit into algebra without ambiguity. You now apply KVL around each mesh. Sum all voltage drops and rises to 0. For resistors only in one mesh, use EIR. For shared resistors, use EI minus IJ times R so you capture interaction. When you hit voltage sources, insert plus or minus according to traversal direction. For dependent sources, express their voltage or current in terms of mesh variables. Once written, collect like terms to form a linear system, with coefficients multiplying each mesh current. You finish by solving the linear system for mesh currents using substitution, Gaussian elimination, or matrix methods. Choose what is fastest. Once you have mesh currents, compute any branch currents by combining adjacent mesh currents, add or subtract as oriented. Verify power balance and polarities. If something feels off, check your sign conventions and the EI minus IJ terms for shared resistors. One key tip: a single wrong sign in a KVL equation is the usual culprit.
Thanks for watching. Consider subscribing if we helped you.